Yes, good morning. Welcome to our day 7 electronics training program. Um, the last couple of days, we learned the fundamental of electronics and followed by the Arduino basics and few experiments. Especially in the last class, we did few projects. Okay. Can you share the projects what we did in the last class in the chat? What are the projects we tried in the last class? Are you understand those projects? Yes. What are the project we performed in the last class? Can you type it in the chat? Street light project, very good. Then street light project, automatic on off street light, that is okay. Then what else? Automatic street light on off control. Then flux sensor. Using flux sensor, I showed you the what? Kana Hari's RA. This is not a personal chat box. Okay. Lux meter, very good. Then followed by weight scale, weighing scale, very good. Speaker we didn't did, no? Speaker we didn't did. Weighing scale we did. Anything else? Actually, that is not a speaker. That is a, what is that? Buzzer. Buzzer that gives LDR. Using LDR we did. Okay. Um, Where and all we are using LDR? Any idea? Where? Motion sensor, I told you to learn. Whether you people learned or not, I don't know. Motion sensor, then ultrasonic sensor also I told you to learn. Okay. So without making much delay, today we are going to start our discussion with a new topic. So please take a fresh sheet. Please take a fresh sheet. Put a today's date in your class note. Okay. Put a today's date in the class note. So we are going to start our discussion with a new concept called actor. This is the last week content, no? So you people recollected all these things very good. So what we are going to do is we are going to start the new topic called actuator. Any idea about actuator? What is actuator? What is actuator? Any idea? Please share your views in the chat. What is actuator? I'm not asking examples. I'm not asking examples. The definition. What is actuator? What is sensor first of all? What is sensor first of all? Any idea about the sensor? Any idea about the sensor? Sensor, we learned, no? What is the definition for sensor? What it does? What sensor does? What sensor does? Yes, sir. What sensor does? It is even the device is or the component used to sense. Okay, what it will do? It will sense, and we need to give the sensed parameter to the our electronic system. Obviously, our microcontroller. Am I correct? So, what conversion that sensor? See, sensor will sense. Okay, that sensed thing we need to convert it into electrical signals. What we need to convert? We need to convert that into electrical signals. Please take a definition. Sensor, the last class definition, sir, not today's actuator definition. Sensor is the one that converts physical parameters into an electrical signal. Electrical signal. That is the behavior of the sensor. What is actuator? It is opposite to the thought of that. If you are giving electrical signal, someone Sanjay said, energy source to mechanical. Very good. The actuator, the general term of the actuator is energy into mechanical output or physical output. Okay, that is our actuator. The actuator, we have a three type of actuators. One is pneumatic, second one is hydraulic, the third one is the electrical actuator. Okay, what we are going to do is We are going to learn today electrical actuators. Okay, engineers, what actuators we are going to learn? The electrical actuators. Though the basic actuators in our Tinkercad system is it is coming under the output. It is coming under the output. Actually, these LEDs also considered as actuator. It will convert electrical signal into what? Electrical signal into what? LED. What LED will do? LED will do what? It will convert electrical signal into light energy. That is also one physical parameter. Okay. But in general, we are considering the mechanical outputs as the major actuators. Okay. So for that, we will take the simple DC motor. Simple DC motor. This is the one of the actuator. It converts. It converts our electrical signal into what? Will convert electrical signal into what? Any idea? Electrical signal into what? Uh, Type of actuators: pneumatic, hydraulic, electrical. Three types of actuators are there: pneumatic, hydraulic, and electrical. We are going to learn the electrical actuators today. So that is simple DC motor. It converts electrical signal into the mechanical movement. Okay. So here I have a DC motor with the encoder. Okay. Then servo motor. Then hobby generator. Generator, the same thing we can use it for the mechanical output also. Okay. These piezoelectric buzzers also considered as actuators. Okay. These things will produce the sound energy. Okay. So our today's task, we are going to what is Sangeet once again? Sangeet, today we are going to start learning the actuators. So actuator is the one, it receives the electrical input, produces the mechanical output. Okay, mechanical output. So the mechanical physical movement it need to produce. Okay, so motors, here we have a DC motor, servo motor. Okay, DC motor, servo motor, followed by any other motors available. See here, no, only this much actuators are available. Okay, this much actuators are available. Ah, okay. See what you are seeing here, all are motors. Am I correct? These motors are coming under the category of actuator. That's all. That is the point we are discussing. Okay. Now you tell me, I want to make this motor to rotate. I want to make this actuator to rotate. How I can rotate this? Any guess? How I can rotate this? What energy we need to give it as an input? Any guess? By giving electricity. Okay, by giving electricity. So I am going to take a, we can take a 9-volt battery. Straight away we can take a 9-volt battery. Okay, and I'm going to rotate it. I'm going to rotate it. So my Tinkercad screen is visible to everyone, engineers. I hope my Tinkercad screen is visible to you people. Yes, okay, done. So now what we are going to do is simply we are going to connect this DC motor, with this DC motor with the 9-volt battery. Okay. Please, you people, listen the class. After some time, I will give a time to do the task. Okay. Now I connected, and I'm going to start simulate it. Yes, my motor starts rotates. My motor starts rotates. Electrical energy is converted into mechanical energy. Successful. Sir, I can do simply with this DC power supply and the straightaway wire connections. Why I want to interface these things with our Arduino? Any idea? Sir, actuator is working perfectly. Even I want on off control. What I can do? I want on off control. What I can do, engineer? Please tell me. I want on off control. What I can do? Today we will learn one more new switch. Let me take this dip switch. Okay. I will teach you what is the dip switch. Very simple. The dip switch has 4 switches in it. Okay. What is dip switch? Okay. What is dip switch? Dip switch is nothing but dual dual inline package. Dual inline package means this is one line, straight line. This is second line. 2 lines are there. Dual inline package. This package is used to fabricate the switch. Therefore, it is called as a dip switch. Okay. Okay. To reverse and certain speed, we need to use Arduino. Very good. Good answer. Muhammad and Sanjay is the right answer. Why we need a are going to interface with Arduino is the right answer. Okay, now listen engineers. What I'm going to do is I'm going to use this dip switch. Okay, I'm going to use this dip switch. Arduino makes it rotating according to the given condition. Very good, Pothishwaran. Very good, Pothishwaran. Given condition. What are all the given conditions? What are all the given conditions? Think about the yesterday's learned sensors. Take a flux sensor. Yes, Kishore. Slow பண்ணிக்கலாம் Kishore. Not an issue. So what I am telling, I connected DC motor with the battery. Yes, done. Then I connected this. Now I'm going to introduce the switch. Okay, now I'm going to introduce the switch. In between, I asked one question. Why we need a Arduino? Few friends are answered, sir, if you want to do the speed control, we need a Arduino microcontroller. And Pothishwaran said, Arduino make to rotate according to the given condition. What are all the given conditions? What are all the given conditions? See, you consider yesterday's learned sensors. Okay, very simple. Yesterday's learned sensors. Take any one sensors and relate with the DC motor, please. Please take any one sensor we learned yesterday or the previous classes and think about the analog input. Think about the analog input and tell me the DC motor motion. Girls, I think no girls present in the class. No girls are answering in the chat. Whether you people are in the class or simply connected and LDR switch. Okay, Darshan, how you can make use of the LDR and force applied. Okay, force apply பண்ணி என்ன பண்ண போறீங்க முகமது? Less force means slow speed, high force means more speed. Am I correct? Any conditions you can create, sir. Any conditions you can create. Can you tell me the ultrasonic with the ultrasonic sensor with the DC motor? Consider you are making some auto parking. Obstacle hit sensor rotate the tire so the car could not hit any obstacle. Yes. So see, very simple. If you take ultrasonic and fitting your in the necessary robotic car, you are making auto parking. How you will synchronize your ultrasonic activity with the car? Any idea? You are going to park. Okay, you are going to park. Consider you are going to park. Consider this hand as a wall. This is a car. Okay, automatically you need to park. So if I fit the ultrasonic sensor, consider this chocolate as a ultrasonic sensor. I'm going to fit the chocolate as an ultrasonic sensor backside of my car. Okay, if it moves towards the wall, what we need to do? By sensing the distance, you need to adjust the speed of the car. Am I correct? So likewise, you can do so many projects. Okay. Now we will get into the fundamentals. Okay. I'm going to take one DC motor and see, please listen. Take the positive terminal, and connect it in the first switch. Okay, if the number is not visible, 1 minute, 1 minute. We take the switch little up, taking the switch little up. Yes. So I am connected positive terminal. See, the terminal name is 1A. The terminal name is 1A. The opposite to that of one terminal is 1B. So if you are giving one input, first input, you need to take the output from the first output. Okay, this is the first output. I'm going to take and connect it to the DC motor. Yes. Now, take the negative terminal and connect it to the negative terminal of the battery. That's all. Now start simulate. Hello, sir. The motor is not rotating. Why the motor is not rotating? What I want to do? What I want to do, engineer? Please tell. The motor is not rotating. What I want to do? I need to turn on the switch. See, it is like a slide switch only. It is like a slide switch only. I'm going to slide the switch to the right hand. Yes, motor rotates with the full speed. Motor rotates with the full speed. Everyone try to finish this task. Take 2 minutes time and finish this task, engineer. Quick. Open your Tinkercad. Open your Tinkercad. Start simulate this. Already done. Who's that? Shah Jahan. Okay, good. Anna, doing parallelly the simulation is good, but you may skip some theory content. Whenever I am teaching or any professor is teaching, okay, you people take the notes first. Okay, notes first, followed by do the hands-on. Okay, doing parallel is good, but you may skip some theory content. Okay, that is our little worry. Please try to follow my procedure. Taking class, while we are taking class, your task is taking notes. Whenever we are giving a time to perform, that time you perform and give your output. Okay. Thank you. Thank you. Yes. Yes. Please share your outputs. Please share your outputs. Let me share your outputs in the chat. Who are all completed? Srihari completed. Good. Kana, definitely I will wait. I will wait. I won't go to the next task immediately. அப்பா இப்பதான் ஒரு கேர்ள் கிளாஸ்க்குள்ள வந்திருக்காங்க. வைஷ்ணவி 234 on switch. What about 234? Madam, you can make use of 234 for some other functions or any other motors. Some other, see, if you see your home switch boxes, we have a number of switches in the switch boxes, no? One switch for the fan, another switch is for light, another switch is for what? That fridge, like that. Your switch box, you have multiple switches, no? The same concept. Have you understood, Vaishnavi? What about the remaining switches? You can connect it with the different loads. Yes. Bharat did. Yes, madam. Google, you solved my one more next task. I plan to do one thing, but Google completed that. Okay. Those who are completed this, use ammeter, measure the current flowing through the circuit. Muhammad completed SEMA. Vaishnavi, he did with 2 loads. Okay, he did with 2 loads. One is for motor, another one is for LED. Very good, Muhammad. Yes. Sir, is the dip switch is the same that in the camera flash? Camera flash, na? Which camera flash you are checking? DSLR camera? Maybe. If you find the image, you share it. I will confirm that one. Dip switch we are using in various places in the electronics, especially the dip switch. Why they created dip switch? No, to mount the switch in the PCB board only they created. Okay, so I saw the output. Now What is the task I am going to introduce in the same circuit is measure the current drawn by the motor. Please connect one ammeter in series with that and measure the current. Very good shake. The good, very good shake done. Now I need a current drawn by the motor. பேட்டரியில இருந்து எவ்வளோ கரண்ட் எடுக்குது ப்ளீஸ் மெஷர் வித் த ஹெல்ப் ஆஃப் யுவர் மல்டிமீட்டர் அண்ட் ஷோ மீ குயிக் how to connect the ammeter in series. Someone who was also Kritik Raj, good. Put a title of today's project title or the content title, Kana. Everyone is doing the exercise, but you forgot to give the naming of the Tinkercad project title. Okay. Muhammad, I don't want this power supply and measure the current. I need a meter to be connected. Please do it, Muhammad. Please connect, separate ammeter and measure, please. Everyone give a, okay. Let me show how to connect. Parallel, you people want to try, also try. Ammeter can be connected. So I'm going to take a meter. So how I can take a meter? You can type it in the browse window, that multimeter. You will get a multimeter. Take the multimeter out. Okay. Take the multimeter out. I want to connect the multimeter as the ammeter. So drop down, change. Many of them measured. Very good. What is the current drawn by the motor? What is the current drawn by the motor? How much? How much? How much, Kana? Current, not voltage, I am asking. Current. What is the current? 140 milliampere. How much? 140 milliampere. Please browse and tell what is the maximum current our Arduino port will deliver. I repeat my question once again. Please browse. What is the maximum current our Arduino port will safely deliver? Browse பண்ணி சொல்லுங்க பார்க்கலாம் engineers, please. Please browse and tell. Meantime, let me give the connection of the second task, what I told, the current measurement. Okay. Please browse and tell what is the maximum current our Arduino Uno will deliver. Browse பண்ணி சொல்லுங்க பார்க்கலாம். No, it is not 200 milliampere. நல்ல தெளிவா பாருங்க சார். Is our Arduino port will deliver 200 milliampere. Check பண்ணி பாருங்க proper. It is giving 200 milliampere. Very good. Who said? Darshan, well said. Darshan சொன்ன answer correct ஆன்னு check பண்ணுங்க engineers. Darshan said 20 milliampere. Is it the answer is correct? Please check others. 40 milliampere. Someone got it 40 milliampere. 20 milliampere in the individual pins. Yes. One more clear answer we got it. Please observe, engineer. This DC motor with the full speed, we want to run the motor. Kana, Navaneet, Navaneet, whatever you gave, no, the capital M means it is a mega ampere. Small m nada milliampere. Okay. Sanjay shared something. Yes, Sanjay. Very good, very good. Sanjay, very good. Kana, everyone please see the Sanjay's chat. He found the application of the div switch. Very good, Sanjay. Are you using this camera in your home, Sanjay? Are you using this camera in your home? Sanjay? Very good. I hope your father using this. Am I correct? Yes? Okay, good. This is the same dip switch, Sanjay. Very good. Same dip switch. 4 options available. I hope the screen is visible to everyone where we are using the dip switch. Okay, good, good. Others also, if you want, take a screenshot of it. Sanjay shared the dip switch with a yellow color highlighted. Okay, someone destroying the. Hi, Potheswaran, you should not connect the meter like this. Wait, Potheswaran. Don't connect the meter like that. That is wrong. I will teach you. Wait, Potheswaran. Okay, now you come to அண்ணா ஃபர்ஸ்ட் இயர்ல எல்லாம் ஆர்வமா இருக்கீங்கடா டேய். இயர்ஸ் மூவ் ஆக உங்க இன்ட்ரெஸ்ட்லாம் சேஞ்ச் ஆகுது கெமிக்கல் ரியாக்ஷன்ஸ்ல. அதை மட்டும் கண்ட்ரோல் பண்ணி ஒர்க் பண்ணீங்கன்னா இந்தியா வந்து என்ன சொல்றது, ஒரு இன்ஃபினிட்டி அப்துல் கலாம்ஸ் கிரியேட் ஆயிரும். அப்புறம் வி வில் கிரியேட் அவர் ஓன் ப்ராடக்ட்ஸ். ஆல் த கண்ட்ரி வில் பை ஃப்ரம் அஸ். ஓகே, எஸ் கம். ஐ வில் கண்டினியூ மை தியரி பார்ட். Thank you, Sanjay, for sharing the practical application. I hope everyone will tell we will. After 1 year, you tell me, I will follow you, what you people are doing. Okay. Yes. Can I, shall I take my part into the second part? So now what we did the motor on off condition and we measure the current. And the conclusion, please take down. Our Arduino Uno board, the individual port can deliver maximum of 20 milliampere only. Now you tell me, if that is the case, Arduino can deliver only 20 milliampere, sir, then how I can drive this DC motor? Anyone please tell me what I want to do? How I can drive this DC motor? Any idea? Yes? Any idea, engineer? Motor driver, very good. Step up transformer, not Darshan. Step up not, sorry, that is wrong answer. Motor driver is the right answer. Okay. Motor driver is the right answer. If you get into the market, you'll find many motor drivers. Okay, you will find so many motor drivers in the market. DC motor driver. DC motor driver. So many drivers are available in the market. Nowadays, it is a very big market also. Okay. In Google, a motor driver, I will explain, madam. Please wait, madam. See, these are all the motor driver ICs. Okay. ICs. These are all the modules. These are all the motor driver modules. Okay. This is one type of motor driver module. It has a separate chip in it. Okay, separate IC inside. So using this you can do. And we have a H bridge ICs. Okay, let me show H bridge motor driver. This is a low cost. This is a low cost driver ICs. These are all low cost. Where is that exact board? I am not getting. 1 minute. Is it my shopping window is visible to everyone, engineer? Shopping window. So as an engineer, whenever you want to buy something, go to this shopping option in the Google. Shopping, this one, this motor driver. So this is the motor driver. In this, we learned a new concept in the last week that is printed here. Can you identify what is the new concept what we learned in the last class? That is highlighted over here. What is that? It is one abbreviation. H bridge motor driver. Potheswaran found it from the Tinkercad. Very good, Sangeet. PWM. Pulse width modulation. Pulse width modulation. Using pulse width modulation technique, we can give an input to this motor driver. This driver will perform the speed control. Okay. Now, the takeaway point is Arduino unable to drive the motor straight away. Therefore, we are going to making use of the driver circuit. Very simple. When you appoint driver, in the practical life, when you appoint driver, please tell me, எப்போ நம்ம டிரைவர் அப்பாயிண்ட் பண்ணுவோம்? When we appoint drivers, that may be to travel is okay. If needed is the one answer. Second thing, if I don't know to drive also, I will appoint driver. Am I correct? Long travel, I want to concentrate in my duty, I can't drive means I will appoint driver. The same way, we need to appoint on driver circuit, acting driver. Yes, we don't have a license. Very good. These are all the different possibilities. Shalini, when we can't do it. Yes, very good, Shalini. Shiki, ஒரு இந்த பேர் எனக்கு எப்படி ப்ரொனவுன்ஸ் பண்ணுறதுன்னு தெரியல. ஷாய் ஃபரிஷா, ஷேக் ஃபரிஷா கண்ணா. Sorry, I'm unable to pronounce this name exactly. எது டெய்லி டைப் பண்ணாலும் எனக்கு ப்ரொனன்சியேஷன் வரல. I will unmute in between the class, you pronounce your name. Okay. Yes. Sorry. These are all very new name to me. Yes. Now I am getting into the Tinkercad part. We are going to learn one simple component can act as a motor driver. One simple component can act as a motor driver. That is the surprise one you studied in your school days. It is a 3-terminal device. The semiconductor part you learned. I'm giving some clues. You need to answer for this. Okay. After diode, you learned the particular electronic device in your school days. It has 3 terminals. Any guess from your side? In the semiconductor, in your school days, you study semiconductor, PN junction diode. After PN junction diode, you didn't study IC. I'm telling it is a 3-terminal device. It has 2 types majorly. You are telling the application as Potheswaran. Potheswaran always answer kandupidichararu. What is that? Transistor. The transistor will act as a basic driver. I will teach you how to connect this. 2 type of transistors studied in your school days. One is NPN, another one is what is this? NPN, another one is what? NPN, another one is PNP. Okay. So I hope you people remember the symbol and all. So time being, I am going to take the NPN transistor. This transistor will act as a switch. This transistor will act as a amplifier. It will do 2 major actions in the electronic circuits. Here we are going to use sorry for the disturbance. 1 minute. Hello, sir. Sir, I'm in the online class. Anything urgent, sir? Sir, please call Ram Kumar, sir, please. I'm in the online class. Yes, okay. Sorry for the disturbance. Where is this? Come to this NPN transistor. Come to this NPN transistor. What we are going to do is, we are going to make this NPN transistor as a switch. Okay. Before that, let me teach the circuit diagram. Please take your class note. I'm going to explain with the paint. Okay. Please take down the circuit diagram, and then you can start give the connection by your own also, or hello, who is the service? Sir, bio student can do so many things. Okay. Bio students means you didn't study physics akana. Bio student na physics படிச்சிருக்கவே மாட்டியா? Service bio means physics வந்திருக்காடா. physics சுத்தமா படிச்சிருக்க மாட்டீங்க. No issues. Learn physics here. If you not learned, don't worry, learn here. Okay. இருக்கும் சார்னு போடுறான், இன்னொருத்தன் இல்ல சார்னு போடுறான். What is the meaning? I know I completed 10th standard in the year of 1998. That time my brother did 12th standard higher studies, like +1, +2. He had a physics and biology. அப்புறம் எதுக்குடா பயோ ஸ்டூடெண்ட் என்னை போட்டு சர்வேஸ் ஹியர் ஆஃப்டர் நோ பயோ மேக்ஸு சார் பியூர் சயின்ஸாக இருக்கும் சார். எனக்கு ஒன்றுமே புரியல யுவர் ரிப்ளைஸ். வெதர் சர்வே ஸ்டடிட் ஃபிசிக்ஸ் தட் அலோன் ஐ வாண்ட். சர்வேஸ் ப்ளீஸ் ஆன்சர். சர்வேஸ் சர்வேஸ் சர்வேஸை காணும். நான் போய் புக்கை தேட போயிட்டேன் போல. சர்வேஸ் சர்வே ஸ்டடிட் ஃபிசிக்ஸ்னா சர்வேஸ் மட்டும் ஆன்சர் பண்ண மாட்டேன்றான், மற்ற எல்லாம் ஆன்சர் பண்ணுறான். பியூர் சயின்ஸ் டே கொஞ்சம் இங்கிலீஷில் டைப் பண்ணுற தம்பி, உங்கள் தமிழில் படிக்க எனக்கு வரல. ஓகே, கம் டு த ஸ்டோரி. டிரைவர் சர்க்கியூட் ஸ்டோரி வி வில் லேர்ன். Hey, hereafter, everyone are engineers. நீ என்கிட்ட பழைய கதையெல்லாம் சொல்லிட்டு இருக்காத. யூ ஆர் நாட் அ பயோடெக் பீப்புள், பயோடெக் இன்ஜினியர். ஓகேவா? எல்லாரும் சேட்ல டைப் பண்ணு. டுடே ஆன்வர்ட்ஸ் ஐ எம் இன்ஜினியர்னு. என்னை டிஸ்டர்ப் பண்ணக்கூடாது. இன்ஜினியர் ஆகணும்னு பிளான் பண்ணிட்டு இங்கே வந்துட்டு நான் பயோ சார், நான் மேக்ஸ் சார், நான் தமிழ் சார், எனக்கு திருவள்ளுவர் திருக்குறள் மட்டும்தான் தெரியும் சார்னா, திருக்குறளில் ஏகப்பட்ட எக்ஸ்பெரிமெண்ட் இருக்கு. ஒவ்வொரு எக்ஸ்பெரிமெண்ட்டும் எடுத்து பண்ணலாம். ஓகேவா? ஓய், ப்ளீஸ் டோன்ட் டிஸ்டர்ப் மீ இன்ஜினியர்ஸ். ஐ எம் இன்ஜினியர், அவ்வளோதான். அதோட முடிச்சுக்கணும். if you are lag in any concept, make use of chat gpt or any other AI tool and learn. Okay, so don't no other category inside this class. Okay, engineer. Come. Now I am drawing something. Please tell me what is this. I am drawing something, some symbol I am drawing, engineer. Please tell me what is this. Oh, my paint screen is not visible, no? Let me share my paint screen to everyone. Please tell me what is this. Still many people are joining from since yes sir, since I shared. Wait, many latecomers are sitting in the lobby. Okay, 1 minute. Few people are want to join. Ma'am, if possible, make them to admit. Oh, no one is there. Okay, I admitted few people. Hello, my dear engineers. Join using official mail ID. Don't form my approval to enter you. What is this, engineer? I done something. What is this? What is the name of this? What is the name of this? It is a 3-terminal device. Am I correct, engineer? It is a 3-terminal device, transistor. Can you name this? What is the name of this terminal? This terminal, please tell me what is the name of this? What is the name of this? Any idea? Oi, what is the name of this? Terminal name. Yes, that is NPN, understood. Please, what is the name of this terminal? Forgotten. Why? Sir, okay. Base terminal. This is base. What is the name of this terminal? Please tell. What is the name of this terminal? What is the name of this terminal? Quick. This is collector. This terminal is emitter. Please take down the symbol. Please take down the symbol. Please take down this symbol. Base, emitter, collector. That's all. Base, emitter, collector. If you take actual transistor, find 3 terminals like this. 3 terminal like this. Okay. If you check it in the Tinkercad also, Tinkercad just now we take a transistor. You will find one thing, very interesting thing. First terminal is C, second terminal is B, third terminal is E. How I can remember this easily? How I can remember this easily? CBE. What is CBE? Coimbatore. That's all. That's very good. Coimbatore people very well know this abbreviation CBE. Yes, the terminal is Coimbatore only, but not Coimbatore. To keep a thing very simple, keep it CBE. That's all. Collector base emitter. Okay, now if I draw this again, the bio people will kick me. Okay, anyhow. Okay, now all are engineer. No, everyone become engineer, so I can draw this graph and ask some question. X-axis voltage, y-axis current. Okay, engineer. Have you learned the graph like this anywhere in your school days? Have you learned the graph like this, engineer, anywhere? 60 mark question படிச்சு வாங்கியிருப்போம் mark. Am I correct? Ah. What are all the regions available in this? கொஞ்சம் quick. இது சின்ன theory. If you finish this theory, you can learn so many things. Okay. I'll put different colors. இது மாதிரிலாம் regions படிச்சிருப்போம். எல்லாரும் எஸ் சொல்றான், but no one is telling the answer. This portion is one region. Can anyone tell me cutoff region? Who is that? Who is that? Cutoff region. ஒரு ஆள் சொல்லியிருக்காங்க. யாரு? பேர் வரதுக்குள்ள ஓடுதுடா. Tanishka Striya. Very good, madam. Which one is cutoff region, Tanishka Sri, madam? Okay, I will this region. This region is a cutoff region. Cutoff region na switch open la irukunu artham. What about this blue color region? Saturation. Very good, madam. This is saturation. Saturation means closed switch. Avladhan, sir. What is this brown color region, madam? What is this brown color region? Any idea? Active region. Very good. Amplifier. Active region, amplifier. Please note down. If you want, note down this graph. There's no issues. What you need to take in your mind is your transistor will act in three conditions. One is active region, another one is a cutoff region, another one is a saturation region. We are going to operate this transistor in cutoff and saturation region. Cutoff region layum, saturation region layum, electronics engineers, we are going to operate now. Cutoff and saturation. Cutoff and saturation region alone we are going to operate now. That means your transistor going to act as a what? That means your transistor we are going to operate it as what? Any idea? Switch. That's all. We are going to operate your transistor as a switch. Okay. So now we will learn the connection, how to do that. Now we can learn the connection, how to do that. Okay. Very simple. Take down the transistor very carefully. Take down the transistor. Okay. Three terminals. Followed by connect this emitter terminal to the ground. Then take VCC from the top. VCC positive. VCC is a positive voltage. If you are not understanding, no worry. Keep it as a, for example, now time being, give it as a 5 volt hour paniko. That supply, you need to connect it across your load. This is your load. இந்த லோடை தான் நம்ம டிரைவ் பண்ண போறோம். ஓகே, this is our transistor. Then put one current limiting resistor in the base terminal. That's all. Now the thing is very simple. Take down this circuit, take down this circuit. My paint diagram may not be nice. I hope you people can draw perfect diagrams. Okay. Take down this diagram. When here you put a high uh, value resistors. Okay. You put 10 kilo ohm resistor போட்டுக்கலாம். High value போட்டுக்கோங்க. Because இது current limit பண்றதுக்கு மட்டும்தான் யூஸ் பண்றோம். 10 kilo ohm resistor போட்டுக்கோ. Followed by, now you tell me, when your transistor will act as a closed switch, open switch here, and when your transistor will act as a closed switch. Please tell me, engineer, any guess from your side? Two conditions. Now your load is not turned on. If you give some supply from the base terminal, then only that transistor will act as a closed switch. Now it is initially open condition. Shall I draw one input waveform in this? If I draw that, it will be, you can take that as a clue. I am giving one square waveform. இப்படி கொடுக்கிறேன். Which condition transistor will turn on? Anyone? When power is applied. Very good. கண்ணா இங்க பாருங்க. Very simple. This is 0 volt. This is 0 volt. This is 5 volt. This peak voltage is 5 volt. When your transistor will turn on? Any idea? When your transistor will turn on? When the circuit is applied from both sides. When current applied from both sides. ஓகே, இங்கேயும் சப்ளை கொடுக்க சொல்றாரு, இங்கேயும் சப்ளை கொடுக்கணுமா, இங்கேயும் ட்ரிகர் பண்ணணும். இது பண்ணோம்னா என்ன ஆயிருன்றாங்க, என்ன ஆயிருன்னு சொல்றீங்க? My transistor will turn on. Okay, now tell me, engineer, you are going to club your own known concepts today. Okay, இங்க வா. You want to generate this kind of waveform in your Arduino board. What program you will use? உன்னோட டிரான்சிஸ்டர் ஆன் ஆஃப் ஆகிட்டே இருக்கணும். வாட் ப்ரோக்ராம் யூ வில் ரைட்? ப்ளீஸ் டெல் மீ. என்ன ப்ரோக்ராம் எழுதுனா உன் டிரான்சிஸ்டர் ஆன் ஆஃப் ஆகிட்டே இருக்கும்? குயிக். வாட் ப்ரோக்ராம் யூ வாண்ட் டு ரைட்? கொஞ்சம் சொல்லுங்க பார்க்கலாம். லூப் இஸ் ஓகே. வி லேர்ன் திஸ் ப்ரோக்ராம் இன் த ஆர்டினோ ஆல்ரெடி. வெரி ஃபர்ஸ்ட் ப்ரோக்ராம் என்ன பண்ணோம்? வி டிட் சம் ப்ரோக்ராம். நோ, first program dakana, very beginning, first program, not series, no digital, right? I am asking the name of the program. Name of the program. Okay, have you take down this circuit diagram? Have you take down this circuit diagram? Have you take down the circuit diagram, engineer, please? Diagram eduthitingla? Okay, now I will show this waveform. You people will be surprised. It's a very simple experiment. Already we learned. I hope. Very good. Who said? Navanida Yogesa. Very good. Light on off circuit, sir. Sir, engineer, please see. Please see. Now I am going to take. Now I am going to take a Arduino board. Okay. Now I am going to take a Arduino board, and I am going to take the oscilloscope. So have you studied the oscilloscope in your school days? Ketana again science groups annuwa. Have you seen the oscilloscope in your textbooks at least? Textbook la? No problem. I will teach you. I will teach you with no time. Listen. I am going to take a multimeter first, followed by oscilloscope. Please listen. Please listen, engineer. Please listen. And I am going to take one breadboard. Okay. Breadboard. Very simple experiment only I am going to perform. No need to bother. Okay. Yes. You saw in hospitals. Very good. Listen. Now I am going to take a ground terminal alone. Ground mattum I am going to take. Ground terminal. Okay. Take 5 volt also. 5 volt எடுத்துக்கலாம். Clear understanding. 5 volt. 5 volt is given. Okay. Now I want to measure this 5 volt. I want to measure this 5 volt. So I am taking multimeter, positive terminal. Oi, Muhammad found a oscilloscope here. Muhammad ஒரு ஸ்கிரீன்ஷாட் போட்டிருக்கார் சார். அதை நோட் பண்ணிக்கோங்க. தட் இஸ் த ஆசிலாஸ்கோப், ரியல் ஆசிலாஸ்கோப். சார் பாருங்க, I started the simulation. I started simulation. What my multimeter shows, what my multimeter shows, what my multimeter shows. Screen is not visible. And I shared the Tinkercad screen. Screen is not visible. Wait a minute. One minute. Wait a minute. Stop sharing. Let me share one more time. Paint screen only visible. Sorry. Okay. Sorry. Kana, the connection and all clear to you, no? Tinkercad screen is not visible. Now check it. Is it visible now? Is it visible now? Yes, sir. I hope Tinkercad screen is visible. Yes? Visible. Come. Sir, this is Arduino board. I measured the 5 volt. Am I correct? The same 5 volt, I'm going to measure it with the help of oscilloscope. Oscilloscope measure பண்ணலாம். Stop simulation. Take 5 volt. Positive terminal. Connect it in the 5 volt. Then ground. Connect it in the ground. What we are getting in this? சார் இங்க பாருங்க, இதுல 5 வோல்ட்னு வருது, இதுல வந்து ஒரு ஸ்ட்ரெயிட் லைன் மட்டும் வருது. Can you see what is the difference between the multimeter and the oscilloscope? Oscilloscope will show the pictorial representation of the output. என்ன output காட்டும்? Pictorial representation காட்டும். Not a square wave. Any waveform you are measuring, it will show it as a output. Okay. Now listen. Now it is showing 5 volt. Now it is showing 5 volt. If you are measuring ground, என்ன voltage காட்டும்? If you are measuring ground, என்ன voltage காட்டும் engineer? Now I am measuring 5 volt measure பண்ணிட்டோம். Ground மட்டும் measure பண்ணா 0 காட்டும். சரி. Now what I am going to do is, I am going to take this terminal to one location. The scope is also I am going to take it to one location, same location. Followed by I am going to take the pin number 13. Pin number 13 in the same position. I repeat once again, very simple. I am measuring the LED blinking output, that's all. LED blinking output. Please compare this. I am going to start simulate. What you people are observing in the screen? Please tell me. இங்க என்ன வருது, இங்க என்ன வருது? Please. What you are observing? என்ன சார் வருது? Here 5 volt வருதா சார்? 5 volt வருது. 50050505. That is nothing but your square waveform. If you want to check the perfect square waveform, if I reduce the delay into further, you people can see the perfect waveform. See here. Sir, can you see the square waveform now? Can you see the square waveform now? Now you tell me. Yes. Now you tell me. Shall we use the same output to make the transistor on and off? Yes or no? My question is very simple. Shall we use this same LED blinking program to make your transistor on and off? Yes or no? Yes, no? If yes, take 1 minute time and observe like circuit diagram connection and give the same and realize how to connect by your own, please. Try பண்ணுங்க பார்க்கலாம். Take oscilloscope, take multimeter and connect. Connect பண்ணுங்க. ஹலோ சோ கால் பயாலஜி பீப்புள், நீங்க ஐசியூல போனா இந்த மீட்டர் தானே மேடம் பார்க்க போறீங்க. பயாலஜி, பயோடெக்கு, ஒரு பாக்டீரியா, வைரஸ் இதெல்லாம் நீங்க மெஷர் பண்ணணும்னா இதை வச்சு தானே சார். ஒன்ஸ் அகைன் ஐ ஷேர் த சர்க்யூட் கண்ணா. ஐ ஷேர் த சர்க்யூட் அண்ணா. any industry invariably you need two things. One is coding, another one is electronics. Okay, any field. So that's why we are teaching these two concepts as a common to you people. Even mechanical you need to learn. If you come to Arivu Patra, you will learn all these stuffs. Okay, don't put a barrier by your own. I am this engineer, I know I want to learn only this. Don't keep like that in your mindset. Okay, please try to do please try to give this connection. Okay, and check the square waveform. If you are not getting perfect square, reduce the delay to 100 milliseconds. You will get the output. Balasujay, very simple. நம்ம எதுவும் பெருசா teach பண்ணல. Okay, Balasujay, you give the connection as such and check the output. Pin number 13 ல connect your digital multimeter and oscilloscope in pin number 13. That's all. Pin number 13. Pin number 13 ல நம்ம connect பண்ணிக்கிறோம். Nothing complex. Try, you will get the same output. Try Balasujay and share the outputs in the screenshot. Yes. What is Divya Darshini? Divya Darshini, what is plus? She shared something plus and she deleted. Yes, sir. Try to do this exercise, then we will get into um, actuators experiment. Quick. And quick வாங்க sir. Quick. Today we'll learn the DC motor on off, then its driver circuit. Quick. I'm giving few more time to complete. Engineer, please complete. Those who are completed, now for your understanding what is actuator, I'm giving some theory content. Now I'm giving some theory content. Okay, please, those who are completed, please take that particular notes also. Okay, what is actuator? It is clearly given. I will share it to you people. Okay, those who are making an attempt, show your output in the chat, please. Those who are completing, give your output in the chat, please. Very good, very good. Many of them tried. Good. Change delay into 100, you will hear waveform. Yes. Change it to delay into 100, you will get a perfect square waveform. Right. Change delay into 100, you will get the perfect output. Good. Done, sir. Very good, sir. Do it. Yes. Shall I continue the session or you want few more minutes to perform? Shall I continue? Because ask close service 1 second. Okay. Now many of them become a teacher in the class. They are taking my role. Thank you. Good. If someone asks the doubts, you people also can answer. I will cross check the answers. If it is correct, you people can take that answer. Nothing wrong. Yes. Shall I continue? Shall I continue or you want time? Shall I continue? Okay. Yes. I'm going to continue. Before that, I'm going to share one screenshot to you people. Okay. You people save that screenshot. Okay. No. If you are taking notes, it may take some time. Okay. So I'm going to share one notes to you people that you keep it as a image for the future reference. Okay. Wait a minute. Hmm. Very simple notes in the chat. Please check it. What is actuator? Please note down this image. This image speaks about, it's a very simple theory concept. Go through it. Okay. So now we are getting into the Tinkercad part. We are getting into Tinkercad part. Is it my Tinkercad is visible, engineer? Is it screen is visible? Is it my Tinkercad screen is visible? Yes. Okay. Yes. Okay. Now go through that image. Go through that image. What are all the things considered as actor, stepper motor, solenoid, relay, linear actuator, pneumatic cylinder, hydraulic cylinder? Am I correct? So take the screenshot safely. Okay, I will give you little more theory content if you want in between also. And in the community group we will share the material. Now listen, engineer. Now listen, engineer. We are going to perform the connection what we learned in the paint screen. Okay, what we learned in the paint screen I am going to perform in the Tinkercad. Please come to listening mode. Don't do anything by your own. Now I am going to take one more Arduino board, one more breadboard. Okay, one more breadboard, followed by I am going to take the required components. Please refer the circuit diagram and tell me what are the components we required. We need a resistor, current limit resistor. What else we need? Please tell. What else we need? We need a load. Am I correct? We need a load. Load, what I am going to do is, I am going to take a simple load. I think Potheswaran, someone already used this lamp, no? Used this lamp to drive the systems, no? So I am going to take that because this lamp draws more current. It is greater than 20 milliampere. That's why only I hold him to not to connect this lamp straight away to the Arduino. Okay. Now we are going to use the driver circuit to make this lamp to glow. You people, what you people are going to do is, you people are going to make the motor to rotate. Okay, come. Now what I am going to do, I am going to take a transistor. So it has 3 terminal, no? See here, if you keep the first terminal itself, it speaks collector, second terminal base, third terminal emitter. Okay, so transistor very simple, sir. If you zoom, you can see the CBE, collector, base and emitter. If you bring the cursor also, the programming engineer very cleverly written that the moment you bring the cursor nearby to the terminal, it will tell about the terminal name. Okay. Now, what we are going to do, I'm going to take an 9-volt battery and then the lamp, then the resistor. So resistor, I'm going to connect it in the base terminal. Resistor, I'm going to connect in the base terminal. Then I'm going to take the 13th pin to apply the triggering in the base terminal. I connected the 13th pin. Please, don't draw parallelly. Please observe what I am doing. Then you people can do your task. Okay. Yes. Then from the collector terminal, see this breadboard is also having a current limit. This breadboard is also having a current limit. You can't drive more current with this. The green color line indications are the conducting plates in the breadboard. If you make more current to flow through this, the breadboard will heat up and it will get melt. Okay. To avoid that, okay, we are going to make this power circuit. இப்போ வந்து ரெண்டு நேம் யூஸ் பண்ண போறோம். இந்த circuit battery and the lamp வந்து power circuit, transistor and Arduino board is a control circuit. Okay, let me give a two name to my circuit. This is control circuit. The circuit going to control the operation. Then this load circuit is a power circuit. Power circuit, we should not connect it in the breadboard. Connect பண்ண என்ன ஆகும் சார்? What it will happen? என்ன ஆயிரும்? What it does? It will make a overcurrent flow in the breadboard and it will destroy the board. Okay, breadboard melt ஆயிரும். ஸோ நம்ம என்ன பண்ண போறோம்? இப்போ நல்லா லிசன் பண்ணிக்கோங்க. உங்களோட இன்னவர் டிரான்சிஸ்டர்ல you have a emitter terminal. We are going to ground பண்ணியாச்சு. Take the ground terminal and connect it. Ground மட்டும் தான் கனெக்ட் பண்ணிக்கிறேன், நல்லா பார்த்துக்கோங்க சார். Now this collector terminal I am going to take it out. Actually, placing the transistor in the breadboard also a little difficult. Okay, but without breadboard, if I connect, the terminals may not be clear to you people. That's why I'm making use of the breadboard. Practically, we need to avoid the transistor also to be not connected in the breadboard because it will draw more current from the system. Okay, now I am connecting the load to my battery. Then the last connection is I'm connecting this negative terminal. Okay, this negative terminal to the Arduino ground. This is the common ground terminal. Only this much I am going to do. Now I am going to start simulate. What happened to the lamp? Dear engineer? Please tell me. What happened to the lamp? What? Blinks. Am I correct, engineer? Blinks. Can you try this experiment? No code I have written. I made use of the actual default code present in the Tinkercad. Default என்ன இருந்ததோ நம்ம அதை மட்டும் தான் யூஸ் பண்ணியிருக்கோம். ஓகேவா engineer? Please start do that. Wait a minute, let me move this power circuit. எங்க வைக்கலாம்? எல்லாமே ஹைட் ஆகுது. ஒன்று விட்ட minute. I will keep here. Is it the circuit is visible to everyone? Our circuit is visible to everyone. Please try to do this, circuit engineer. Sir, very good, very good. Now, next task. Next task. Okay, let your friends finish. Everyone finishes this. Next task. Don't do in the same project. Okay. Create. Actually, now the second task is very simple. Make your DC motor to on off in the same fashion. That's all. Those who are completed this task, I am seeing so many responses. Very good, very good. Who completed now? Gaudaman V, very good. Then Muhammad already completed DC motor. Okay. Then Sajana. பேர் என்னடா Sanjana. Okay. Then Ratnadeepa. Second Ratnadeepa in RTC. Already போன வருஷம் Fab 3 1 lakh winner ஒரு Ratnadeepa. Now second Ratnadeepa. Potheswaran did. Potheswaran did. Bharat did. Then 4 all completed. Muhammad. Yes. Okay. Those who are completed, Varsha did. Sanjay did. Rajendran Parthasarthi. Oh, it's mine. Okay. Yes. Now come to same circuit diagram. Same circuit. But don't remove the lamp and connect DC motor. Do separate connection. Make DC motor to on off. Shalini did very good. Shalini, have you did with the new project or you removed the lamp and connected? Shalini, if you remove the lamp and connected now, please do one more project in the Tinkercad, please. Selva, good Selva. Move to DC motor part. And I need 2 screenshots. 2 circuits in the same screenshot I want. Okay, because you people may remove the lamp and do the project. I want 2 different projects in your workspace. So share the output with a single screenshot, lamp as well as the motor. Quick. If you do with the motor, I will teach you what? Relay. I will teach you relay. Quick. If you check the actuator list, I will share my ChatGPT prompted screen to you people. Okay. Is it my ChatGPT screen is visible to everyone, engineers? ChatGPT screen visible? How simple we can teach? I asked chat. What is actuator? Just I typed. An actuator is a device that converts energy into physical movement. That's all. Very simple definition. Sensor detects something, control decides what to do, actuator performs the action. Okay. So in this, we learn DC motor. Okay. DC motor. You may ask, sir, lamp light kudukudula, sir. Why that is not taken into consideration now? Those things will be considered as a lighting system. So it is going under the different category. That's why it is not mentioned here. Servo motor, stepper motors are special motors. Servo motor moves with a specific angle. Stepper motor rotates in the precise steps. We will teach you what is that. Do you know what is solenoid? Where we are using solenoid, engineer? Where we are using solenoids? Any idea? Where we are using solenoids? Good Sanjay. Solenoid நம்ம எங்க யூஸ் பண்றோம்? Windmill இல்ல கண்ணே, coil, OD wire. Okay, where we are using? Coffee maker, you know? No, not in the water heater. Do you know that vending machines, coffee vending machine, water doctors? உங்க வீட்ல வாட்டர் டாக்டர் இருக்கா? யார் வீட்ல வாட்டர் டாக்டர் இருந்தா போட்டோ எடுத்து அனுப்புங்க பார்க்கலாம். குயிக்கா ஃபோன் எடுத்துட்டு ஓடி போய் டேக் அ போட்டோ அண்ட் ஷேர் இட். உங்கள் வீட்டில் இருக்கிற வாட்டர் டாக்டர் எனக்கு ஃபோட்டோ அனுப்புங்க பார்க்கலாம். குயிக். வாட்டர் டாக்டர், நாட் அ வாட்டர் ஹீட்டர். உங்கள் வீட்டில் இருக்கிற வாட்டர் டாக்டர் எனக்கு ஒரு ஃபோன் அனுப்புங்க. ஷேர் த இமேஜ் ஆஃப் வாட்டர் டாக்டர் ப்ளீஸ். குயிக். ஆர்ஓ, எஸ் ஆர்ஓ பிளான்ட் இருக்கா? கிச்சனில் இருக்கும் சார். அங்கே கிச்சனுக்கு போயிட்டு சாப்பிட உட்காந்துடக்கூடாது. ப்ளீஸ் டேக் அ ஃபோட்டோ அண்ட் ரிட்டர்ன் பேக். உங்கள் வீட்டில் இருக்கிற ஆர்ஓ இதை எடுங்க. ஃபில்டர் த வாட்டர். அதை ஒரு ஃபோட்டோ எடுத்துகிட்டு வர சொன்னேன் குயிக்காக. ப்ளீஸ் டேக் அ ஃபோட்டோ அண்ட் ஷேர் இட் குயிக். ஐ வாண்ட் யுவர் ஓன் வாட்டர் டாக்டர்ஸ் இன் த ஹோம். குயிக். எடுத்தாச்சா? ஃபோட்டோ வரமாட்டேங்குது. அருண் ஜே, குட் அருண் ஜே. I am not having, sir. Sir, if anyone have, please take a photo of it and share it. So in the water, no sir. யார் வீட்லையுமே இல்லையாடா வாட்டர் டாக்டர்? அது எப்படி? ஓகே தர்ஷன் ஓகே. No one have the water doctor in your home? Google we have. I want real water doctor in your home. Water. It is a water purifier. Water purifier in your home. Okay. The water purifier in our home has Malbar. Boy, netla போய் எட்டு வந்துட்டார். Very good. Who made it? In the water doctorல this water doctor, can anyone tell me, once the water empties, how it gets filled? Srihari, யார் first share பண்ணாங்க? Who shared first? Who want to by motor? ஒரு மோட்டார் ஆன் ஆஃப் ஆகுது கரெக்டா இன்ஜினியர்? ஒரு மோட்டார் ஆன் ஆஃப் ஆகுறது, that is good. Motor will turn on. Who will control the water flow? Who will control the water flow? Water flow யார் கண்ட்ரோல் பண்றது? That is your solenoid. Okay. So without making much delay, you come solenoid. Very good. The solenoid is the one. And one more thing, if you get into the fancy restrooms and the wash basins, like if you bring the hand front of it, water will come. Very good, Shagana. Very good. In this water doctors, the water flow control is controlled using solenoid, and the water pumping done with the help of the DC motor. Water pump panni, it will take a water inlet. The moment you press that knob, the solenoid will get turned on. Okay. What is solenoid? How it works? We will teach, no worry. Then linear actuator. See, this pneumatic and hydraulic. Pneumatic and hydraulic na compressed air is the pneumatic. Pressurized fluid is the hydraulic. நம்ம பஸ்ல டோர் ஓப்பன் ஆகுது இல்ல, இந்த பஸ் drivers are pressing the button, the doors are getting open automatically. Whether it uses a pneumatic or hydraulic? Any idea? Pneumatica, hydraulica? Someone find the solenoid also from the water doctor. Very good. ரொம்ப ஸ்பீடா இருக்கிறாங்க. Very good. I want to know the pronunciation of this name first. அவங்க ஆன்சரா போடுறாங்க, எனக்கு பேரை ப்ரொனவுன்ஸ் பண்ணவே தெரியல. I am unmuting you. Please, boya girla, wait a minute. The பேர் எப்படி ப்ரொனவுன்ஸ் பண்றது? How to pronounce this name? Hello, Mike. கண்ணா உங்க மைக் அன்மியூட் பண்ணிக்கிறேன். Please pronounce your name. ஷாஜகானா? ஏண்டா கண்ணா, am I correct?
Yes, sir.
Okay. நான் கேர்ள் நேம் ஷாஜகான். ஷாஜகான் கண்டுபிடிச்சிட்டாரு. Where you find the solenoid, ஷாஜகான்?
It's in the RO system, sir.
RO system. Very good. Can you zoom 1 minute? Let me find it in the chat. Kana, are you a biology students or physics, the math students?
Sir, computer science,
அடப்பாவி நீ
maths.
பயாலஜியா இருந்தா உன்னை வச்சு எல்லாம் மோட்டிவேட் பண்ணலான்னு பார்த்தேன். ஓகே.
Yes.
The biology people, they are penetrating new virus into the class. We are bio. We will address
Bio
all
students
bio
has
people.
physics also, sir.
Ah, they
Maths,
have a
physics.
physics, no? They have a physics, no?
Yes, sir.
But they are not. They are telling we didn't study it. Okay, very good, Kanna. I will. Okay, you unmute. I will continue the class. Okay.
Yes, sir.
Yes,
Thank you.
good. Yes, good. Thank you. ஷாஜகான தான் எவ்வளோ நேரம் கஷ்டப்பட்டேன்னா ஓகே நிமேட்டிக் அண்ட் ஹைட்ராலிக் நிமேட்டிக் ஃபார் வாட் சார் பஸ்ஸில் இருக்கிறது நிமேட்டிக் சார் ஏர் சவுண்ட் கேட்க பார்த்துருக்கோமா whenever the driver presses air sound will come that is pneumatic actuators hydraulic where we are using any idea compressed oil and it will lift the very big weights in our பிரேக்ல யூஸ் பண்றாங்க ஜேசிபி எர்த் மூவிங் வெஹிக்கிள் ஜேசிபி இஸ் அ கம்பெனி நேம் ஜேசிபி இஸ் அ கம்பெனி நேம் that is the correct name is earth moving vehicle cold press very good cold press crane all these things we are using hydraulic now come to the next part dc motor also you people did know dc motor connection also you people did if someone not did means let me do the dc motor connection followed by I will teach the relay relay is the next actuator followed by we have so many works servo motor we have I will teach you one by one don't worry now I am taking the same circuit okay transistor is it Tinkercad screen is visible engineers is it Tinkercad screen is visible engineers this Tinkercad screen is visible yes sir okay now I am control is the time and the breadboard copy okay now I am taking resistor and the watt I'm going to take DC motor okay DC motor keeping DC motor connection in the breadboard is okay but long run these motors will destroy I will take this DC motor the hobby DC motor okay yes now listen the same connection I'm going to give ground I'm going to connect it in the breadboard then here then this battery terminal ground also I'm going to connect it in the ground followed by emitter terminal I'm going to connect in the ground then pin number 13 I'm going to take and connect it to the base terminal triggering current limiting resistor terminal okay for better understanding I'm going to change the color of it then collector terminal I'm going to connect it to the load that is my DC motor ground terminal color change again okay then this positive terminal I'm going to connect it to where battery that's all I did the connection motor on off frequently happens okay so if you want to change the speed of it we want to change the speed of not speed the frequency of operation on and operation means what you can do any idea what I can do I want to change the frequency of on and operation what I can do quick what I can do I can change the delay Selva very good Selva the delay I need to adjust so if I adjust the delay into 2 seconds see I'm making motor on time to 2 off time to 1 please observe motor will turn on for 1 minute 2 minute off for 1 minute I hope you people understood we can able to control the motor using straight away connecting with the battery like this but as your friends said in the morning desired outputs customer need you can do only with the programming boards can do with only programming boards. Okay. Now we will learn the one more fellow called relay. Where is that relay? What is relay? Relay is the electromechanical switch. Engineer, can you see the relay in my window? Can you see the relay in my window? Can you see the relay in my window? Yes? Okay, yes. Wait. This relay is a electromechanical switch. That's all. What is this? Electromechanical switch. I will teach this relay. I will teach this relay operation again with the fundamental circuit of one 9-volt battery. Okay. The fundamental circuit first we will do, then we will go with the programming part. Always, if you learn the concept like this, it will be good. Take a battery and, and the relay. Okay. So what I am going to do, I am going to take one more switch. Now I am taking, learning the new thing is good in the life. So now I am taking this switch. What is the name of this switch? Dip switch, DBST. No need to worry about the names and all. Okay, dip switch with a double pole single throw switch. Okay, and during Arivu Patrai, we'll teach all these concepts. You don't worry. What is this is? What is this is? What is the difference between the previous switches and these switches? Here you can control both the positive negative with the help of the switch. In earlier connections, what we did, we will control only the positive. Now I am going to control both. Okay. Now come to the, see, these two are the input, these two are the output I am going to take. Okay. Please listen. How many terminals are there in the relay? Please count 1, 2, 3, 4, 5, 6. 6 terminals are there. 6 terminals are there. Please take down this diagram alone. Please take down this diagram alone. ஒரு diagram இருக்கு பாருங்க, ஒரு சின்ன coil symbol. Please take down that diagram alone. Engineer, please. இந்த diagram மட்டும் drop பண்ணுங்க, ஒரு screenshot எடுத்துக்கோங்க. இதுல what I am going to do is, these two terminal are the coil terminal. Note பண்ணிக்கோங்க. Terminal 5 and 8 are the coil terminals. Coil terminals. Inner terminals? Coil terminals. Now what I am going to do is, I am going to give a positive supply to the one coil terminal and ground to the other coil terminal. I am going to apply 9-volt supply to the coil. If I give a supply to the coil, what will happen? It will get energized. If it get energized, what will happen? See here, sir. Hello, sir. Is it my Google Chrome screen? My browser screen is visible? My browser screen is visible? Hello, sir. Browser screen visible irukka ellarthukku? Yes, sir. Yes or no? Yes. Please see here. Please see here. This is the relay. See, this is the relay. If you energize, okay. I hope my YouTube screen video is visible and it's audio also. what are the two parts available in the relay? One is the coil, another one is the contact. Okay, coil and contact. Once you energize the coil, this contact will get close and open. Understood? Close and open. Okay, so the same thing we are going to see in the Tinkercad. The same thing we are going to see in the Tinkercad. Wait a minute. Wait a minute. Okay. Now I am coming to Tinkercad screen. Hot water. See here. I am going to start simulate this portion. Start simulate. Still the coil is not energized. Please observe. The moment I turn on, what happens, engineer? கொஞ்சம் நல்லா observe பண்ணுங்க. Please find these two terms. This animation alone, I am making switch on and off. What is happening? What is happening, engineer? Can you see the animation in the relay? Can you see the animation in the relay? Can you see the animation? Coil energizes, open, close, open, close. Can you see this? Yes, sir. So now what I am going to do? I am going to connect the load. I am going to connect the load. Okay. Please observe. The operating voltage of this lamp is how much? Last class we checked, no? Initial classes we checked, no? The operating voltage of this lamp. Anyone tell, please? Operating voltage of this lamp. Not 5 volt Purushothaman. This lamp. See, I am connecting this lamp. Operating voltage of the lamp in the 12 volt. Am I correct? See, this is 12 volt supply. This 12 volt supply I am going to control via the relay. See, here I am going to connect the 12 volt supply in the common terminal. The name of this terminal 12 and terminal 1 is called common terminal. I am going to name this terminal as a common terminal, COM. Then this terminal, which one? The terminal number 6 is called NO terminal, normally open. Okay. The name of this 6th terminal is called NO. The name of this 12th terminal is common. Okay. So what is NO means? Normally open. NO means normally open. Normally open. The moment you energize, it will get close. That's why the name of the terminal is called normally open. How I am going to connect is very simple connection, engineer. Very simple connection. One terminal connected in the common. Other terminal I am taking as output and I am connecting with my load. That's all. Okay. I am going to give a different colors for this for better understanding. This also I am keeping as a yellow for better understanding. Is it the yellow color is visible in your screens? If it's visible, so we will keep the same color. Else we will change some other color. Is it yellow color is visible in your screens? Yes, sir. Now you see, engineer, I start simulated and I am giving the voltage as a 12 volt. I am going to give the voltage as a 12 volt and I am going to turn on the system. Lamp on off agada, sir. You may ask, sir, we can connect the switch directly in this power supply, no? Why I need to connect one more relay in between, a 9 volt in between? The story is simple. The story is simple. We study two type of circuit. This left-hand side circuit is called control circuit. It operates with a very low current and very low voltages. The right-hand side circuit is a power circuit. The beauty is, if you learn this connection, you can operate with a AC or DC with high voltage or high current circuits. But my humble request, don't operate with the AC supply in the home. Okay, don't operate with the AC supply in the home. Where we are using the relay is the next question. Where we are using the relay? Any idea from your side? Where we are using the relay? Any idea from your side? Else I will give you one small scenario to you people. Whenever the power cuts off, your refrigerator won't turn on immediately. Why? Any idea? Power cuts off and resumes back. Your refrigerator won't turn on immediately. Why? What is the reason? Auto on-off system is available. Yes, sir. It take time. Why? Which one gives the time delay? What is it inside your refrigerator or above the refrigerator we are keeping something? Yes, above the refrigerator we are having the stabilizer. Inside the stabilizer we have this electromechanical switch called relay. Electromechanical switch. What is relay? Relay is a electromechanical electromechanical switch. Why this is called as an electromechanical switch? Inside the switch we have a electrical as well as a mechanical component. Coil is electrical component, contact is a mechanical component. Am I correct, engineer? Therefore this fellow is called electromechanical switch. Now what is the task we are going to do? Any guess from your side? What is the task we are going to do? Instead of giving this 9-volt power supply and making the system to operate manually with the switch, now we are going to connect with whom? Connect with whom? Our Arduino. If you are familiar in this circuit alone, please tell me, I will teach you that part. Else you take some time to simulate this, then I will teach that part. Quick. I want minimum 10 to 15 outputs of this relay. From that only I am clear that you people learn this. Then I will teach the next concept, how we can connect this relay with the Arduino board, not the lamp with the Arduino board. I need to connect relay with the Arduino board first. Okay, I need to connect the relay with the Arduino board. The Arduino board will take care of the relay will take care of the lamp. Okay, I hope you understood the logic what I am telling. So we need to connect the relay with the Arduino board. Once Arduino board takes care of the relay on and operation, you can take care of anything. This lamp, any higher rating motors, even transistor. Transistor what we use no, the transistor has its own current limit. If it exceeds, we can go with the relay to operate. Relay will operate with a very higher current rating. Can you see what is the maximum current the relay can handle? What is the maximum current the relay can handle in the Tinkercad website? Please check it. What is the maximum current that relay can handle? Tinkercad relay, what is the maximum current it will handle? Quick. Please check the screen and tell me what is the maximum current that relay can handle. Yeah. No, not 250. No, 125. I am asking current value. I am asking the current value. Current value. All are typing voltages. Please check the 3 ampere. Very good. 3 ampere. Dharani Dharan correct. So maximum 3 ampere, this fellow will drive the load. If the load current exceeds 3 ampere, we can't use this relay. Okay. In the market, if you go and buy in the market, okay, again relay I am show you in the market how it is available. Okay. Always my suggestion, go to shopping, Google shopping ponga. No need to shop. Okay. Okay, relay spelling தப்பு பண்ணிட்டோம். Relay. Okay, now Google shoppingல போங்க. This is our relays. Anyone seen this relays in your school days or somewhere? The relay எல்லாம் எங்கேயா பார்த்திருக்கீங்களா sir? Have you seen this relays? Someone holding the real relay in his hand. Kana Google, is it a Google image or you have this relay in your hand? Google, Muhammad, you have. Google shared. It's my very good Google. Can you share the full image of the that relay board? Again, Google. Any electronics engineer in your home, your brother or your father, who is doing electrical work, or you bought for your school projects? Google. Yes, Google. Okay. Engineer, listen. This is the relay in your school you bought. Okay, very good. See, actually, this is the relay. 1 minute. This is the whenever you are going to the market, no, you will find two things: the particular unit and its module. Okay, actually, I will show you the regular relays what you people use in your projects. See, actually, this is the relay module engineer. If you buy the relay module, no, the why this is navigating. See, since our Wi-Fi connection is restricting few things, I'm unable to go inside this. Okay. So actually, whenever you get into the market, if you type relay alone, not a relay module, we don't want the relay module. Relay மட்டும் எடுத்தீங்கன்னு வச்சுக்கோக்கண்ணா, this blue color alone is the relay engineers. Okay. Blue color alone is the relay. See, this unit alone is a relay. It start from 25 rupees to some rate. We can buy this relay. If you see these relays in the market, it has only 5 terminals, not 6 terminals. These relays. If you observe this relay, what is the maximum current we can uh, draw from the particular relay? Can anyone tell me? What is the maximum current from this relay? I am showing some relay, no? 10 ampere. 10 ampere. Okay. What for these three terminal and all we will teach you now. So this is the relay. The cost of these relays are just 25 rupees. If you make it into the module, no, the cost is different. Okay. Relay, we have so many types. You no need to worry about the different types. Now we will come to the Tinkercad. Now please closely listen my words. Consider this circuit diagram. Now please observe my words alone. Consider this circuit diagram. What circuit diagram I am listing to you people? எது உங்க கண்ணில் காட்டியிருக்கேன்? What I have shown engineer? எதை காட்டியிருக்கேன்? DC motor on off control, no? What you people need to do is, again, keeping the relay in the breadboard is not highly advisable. Okay. Very simple. Take this relay. Okay. Remove this motor and connect this relay. First task. Remove, no, don't remove from the same circuit. Else you do one thing, you people, take a actuator part 2. Okay. Take the project as a actuator part 2 and create a new project for the relay and then connect lamp and other stories. Okay. Take the actuator part 2, create circuit, Someone connected. Kana transistor and all, if you keeping in outside now, it may not be good. Okay, the breadboard la வைங்க. Part 2, that is your relay connection. Okay, I am also doing from my side. You people will also do. Okay, who is finishing first? We will check. Okay, I am taking Arduino board, breadboard only to keep the transistor and other stuffs. Okay, remaining things I am going to keep it outside only, not in the breadboard. Okay, here I am going to take what? Shall we take the lamp? Lamp now looks nice. So looks nice, and also the operating voltage of the lamp is different. So thereby you can practice how you can interface the higher current rating devices with your Arduino board. Okay. Where is what else do I need, sir? I need a transistor to take. Okay, where is the transistor? Transistor. Transistor I took. Then I need on resistor. Then 9-volt battery. I need on resistor. Then 9-volt battery. 9-volt battery. Why we need? No need. Arduino we have. Yes. Come here. Relay. The main fellow. The main fellow. Main component is relay. Yes, that's all. The power circuit I am going to keep it out. Only the control circuit I am going to keep it in the breadboard. Please practice that. That will safeguard your breadboard, else your breadboard will get melt. Okay, ground alone I have connected, followed by relay on off, relay on off, relay on off. What is the operating voltage of the relay? You check. It is actually this is not given here. Okay. For this we need a one more power circuit. No, you need a battery to turn on the relay. 3 powers. Battery. You can drive from the Arduino main 5-volt power supply. Sometimes your board will get damaged. That's why we are using separate power source for the your relay operation. Okay, take the ground. Okay, then again pin number 13, trigger. And is it the concepts are clear to you people? Difficulty irka sir? Difficulty irkana or chinna request. I am giving the recorded video. Okay, on the videos go through பண்ணுங்க. Okay va? Repeating again may take some time, engineer. At the end of the session, if you stay back, I will teach. Okay, that's not an issue for me. But if you ask right now, it is little difficult. I made the relay connection, the different color, and then this terminal to this positive, then this ground to this ground common. That's all. Let me check the relay is operating properly. Then I will connect the load. You can do step-by-step circuit like this also. Okay, I'm making system on and I'm checking whether relay is getting turned on and off. My relay is getting turned on and off now. So that means my system, my connection, everything is perfect. Now the part is power circuit part. Up to this, all are control only. Okay. Yes, Kana. In the circuit, no, in the relay connection, no, up to coil is the control circuit only. So I can keep relay here. Partially வச்சா relay உடைஞ்சிரும். என்ன பண்ணலாம்? சரி வெளியே வச்சுக்கலாம் விடு. Keep it outside alone. Okay. Because you people are going to use the relay module. That time that will be out of the circuit only. Now I need to connect the lamp. So lamp positive terminal, I am going to connect it with the common terminal of the relay, followed by the NO terminal I am going to take and I am connected to the lamp. Then Negative terminal. That's all. Set the voltage into 12 volt. That's all. Make the system on off. That's all, Your Honor. Try to do this connection. If you want, let me share this screen also you to you people. So with this, what we learned today is what is actuator, how you can make use of the actuators interfacing with the Arduino to get the desired outputs. Okay. So sharp 12 we completed. Others also try to share your outputs. Meantime, I will share you the feedback form. My humble request. 300 people are present here. Okay. Try to give a feed. Everyone try to give a feedback. Your feedbacks will be monitored by our higher officials. They are asking, you are taking class for these many kids, but why you are getting least feedback? They are asking, please help us. Give 100% feedback, engineers. Okay. Let me share the feedback in the community forum. Everyone try to complete your work and share your outputs. Quick. Any doubt so far you can ask. Any doubt so far you can ask. If you want me to unmute your mic also, you can request me. I can unmute your mic and you can ask orally also. Yes, engineer. Feedback form of today's date, 27/8/2026. I shared the feedback form in the community. I will also share the same in the Vaishnavi, good Vaishnavi. Feedback chat also. Yes, madam, I will share in the chat. I will share in the chat also. I will share in the chat. Any doubts, please ask in the chat. What we learned today also, you can type it in the chat as a consolidated learning quick. What are all things we learned today? Please type it in the chat. If you have a LinkedIn issues, please stay back and ask me the doubt. I will tell you what we can do for it. Okay. Muhammad A left. Please stay back. Please stay back for 5 more minutes. Please stay back 5 more minutes. They started their own regular questions. Regular questions they started. Someone shared. Thank you, Sanjay. Sanjay shared the form in the chat also. Please try to give feedbacks. September 2nd week confirm, engineer. Okay, September 2nd week. September 2nd week. They will inform to you. Okay. Yes. Yes. Please give the feedback. Meantime, take down the feedback I've done now. Yes. Any query doubts? What we learned in the today's class. Anyone can take a photo of your class note and share it in the chat. Anyone, please take a screenshot of your class note and share it in the group, the chat. What you people wrote, I will need to let me check. So by the time, very good, very good. Driver circuit you have drawn on the diary. Day 7 activator, driver circuit, good. Now if you find free time, add few more contents also. Kind of put a heading as a driver circuit. Okay. Put a today's date and take it as a driver circuit. Okay. The last part of the today's classes regarding your mini project. Regarding your mini project, it is an individual project. Point number 1. Point number 2. Only simulation is enough. That too with the Tinkercad. You can take any challenge project and useful project, real-time projects with the help of Tinkercad. The submission format of your Tinkercad output is a two thing. You need to share your project output to us. We will share on a Google form or the Teams form. You need to share the Tinkercad simulation link, followed by you people need to share the 3 minutes explanation recorded video. Is it clear, engineer? What you need to do? You need to choose any one challenge project by your own using Tinkercad simulation, followed by you need to record your work of 3 minutes video. Screen recording you need to do. Your face should be visible. Who explaining we want to see along with your project output. Okay, we will share you the Teams form. The best projects will get appreciation definitely. Once you come to the campus, you will get appreciation. So take it as a challenge. Try to do that. Any queries in the today's class you can ask. Any queries in the today's class you can ask. Please ensure, let me check the feedback response, how many of them completed. Wait a minute. And as usual, those who want to stay back for the hackathon class, you can stay back. Those who are having doubts also stay back. Wait a minute. Now your attendance is also considered by your feedback forms. So please careful. And also if you want to join in any activities, we will check your all day work, all day feedback, attendance, everything. So keep in mind. Let me stop the recording if you don't have any doubt in the today's class. Thank you very much. What is the task we are going to give is try to do analog write function to make the DC motor speed control. Very simple task. Try to do the speed control of the DC motor is the today's task. And also you can make your own creativity to do the actuator interfacing with any one of the experiment, flux sensor experiment or the ultrasonic or the force sensor, anything you can make use it to experiment your actuator interfacing challenge. Okay, try to do that. So this I'm going to conclude the actual class. Whoever want to listen the hackathon inputs can stay back. Okay.